here is an example of when we actually have data in a run, and we want, let's say we want to zoom in or zoom out on the data. There we go. So we've now zoomed in somewhat. We can zoom in further. This is making our distance, so that went too wide. So now we can see the type of width the peak has. You can also expand the y-axis. For example, if you were not able to really see the peak because it was so flattened. And here is where we will want to adjust the integration. So that can be done both by specifying manual timings or by clicking this box. So we could choose adjust peak expectation window or adjust brackish shutter windows. We may not use the brackish shutter, but within this, like let's say we adjust the peak expectation window, that allows us to click on here. While it's red, we can drag back and forth, so you can see if you wanted to truncate part of the peak, but in this case, let's say we want to keep the whole shoulder on that peak. Now that that's set, it's about like it was, we would say, let's just say cancel, because that will not save our move, but we would say rerun peak detection, and then it would give us new integrated areas associated with that peak. So now we've lost our data again, so we'll need to shrink it back in to view it. It's a little rough. Too much data, so we want to shrink down these peaks a little bit. There we go. So we can see them all again, and then if we want to just zoom in on individual peaks, you'll see here it's labeling. We have like a 1 micromolar NH4 standard, a 5 micromolar NH4 standard, a 10 micromolar NH4 standard. Now, if we want to know, you can see maybe on the very bottom here, it's giving us a tiny bit of data that's sort of cut off about it's happening at 27 seconds, what the analyte is, what the concentration supposedly is. However, if we want to see like the peak areas associated with each of these data points, the best way to do that is to close out of this for now. I'll minimize this. And then if we go to the actual, just the computer itself, actually let's go in through double clicking this computer from the desktop, going to the E drive where the data is stored. We want to go to Omnion data. We want to go to the lab, there we go. And then actually from in here, this was the file that we saved today. You can see I saved it at 12:05 on April 5th. We'll double click that, open it up. And then, for example, here in spreadsheet form, we have that NH4 10 micromolar standard. And if we come all the way over, the peak area associated with that is 0.276. So, for example, we have the 1, 5, 10, 20, 30, and then we can take these peak areas from the spreadsheet, and then we could plot those against the known concentration, and we could solve for our calibration curve. Then we can take our other peak areas from our unknown samples, and we can take these values and plug them into the curve that we create from the standards to identify what concentration the sample itself is at. Because we know that the same volume of standard of a given concentration was injected as the same volume as was the same volume of sample, and that is because we use the same sample loop size, which controlled the injected volume. So anyway, this spreadsheet contains much more information than we actually need. It also helps us keep track of which cup number our sample was in. So it's these S are indicated when it's a standard, and you can actually just indicate the cup number itself without the S when it's not a standard.